Good morning, students. For Standard 12, today we are going to study about crossing over and the techniques of mapping. Now, first of all, we have to know about crossing over. This is particularly studied in the chapter of cell division. Crossing over takes place during meiosis and in prophase 1. Now, what is that? That there is a mutual exchange of the block of chromosome from the two non-sister chromatids of the homologous chromosome. That means when the reduction of the uh, chromosome is taking place, between each homologous chromosome there is an exchange of the genes at particular region we call the chiasmata. Now let us take for example, like in prophase 1 during the zygote, there are two sets of chromosomes, the paternal and the maternal chromosome. And suppose they have genes like A, B and small a and small b. During the diplotin stage, from the diet they go to the tetrad stage, each of the chromosomes they divide into sister chromatids. Now, during this diplotin after the packaging stage, some of the chromosome gets twined up or attached at a particular point, and these points are called the chiasmata. Now, in this chiasmata region, there is an exchange of the genetic material. So, some of the genes, like say for example, this is capital B, will go to this side, and the small b will come to this side. So, there is exchange of the genetic material. Now, when the meiosis is taking place, first division will be across this, and the second division will be across this. So, we get four sets of chromosome. So, that will have A, B. Second one will have A and small b because the small b has exchange over here. Here the third one will have small a from this and capital B because it has B, capital B has come to this side, and this one will have the original small a and b. So you can see here that there are two parental and two recombinants. Now these two recombinant genes, they call this is a result of the crossing over. That brings what we call the linkage, or what we call the linkage between the chromosomes. So if it is distant apart, then we say there is a chance of incomplete linkage is more, and if they are close, there is a complete linkage. Now crossing over types are of three types, like single crossover, if there is a single chiasma like this. If it is attached at more than one point, then we have a double chiasmata. If there are more than 2 points, then we call it a multiple chiasmata. Now, let us come to this, that what is chromosomal mapping? Chromosomal mapping is the relative position of the genes on the chromosome is known as the chromosomal maps. Now, this crossing over takes place among the genes, and we express it as a percentage of crossover. Now, this percentage of crossover is directly proportional to the distance between the two genes, as because most of the genes are said to be in a linear position. Now, this was found by chromosomal mapping, or the mapping technique was found by Albert Sturtevant. And mapping technique, there are certain techniques. Now, what are the assumptions of the mapping technique? The first assumption is that the placement of the genes in the linear order. That means all the genes that are placed, they will be linearly placed. Suppose A, B, or say C is here, D can be here. So the genes are linearly placed. Second is the distance between the gene is the percentage of crossover. There is a direct relation. That means suppose A and B, we say 10% crossover. So 10% crossover means we say that it is 10 units separated. Now this is expressed as centimorgan, decimorgan, or morgan according to the units. The units can be smaller, unit can be larger. So since it was found by Morgan, so in name of Morgan, this unit is given as like that. Now here we will take an example of the mapping technique. Suppose here A, B, C and D, there are 4 genes are there, and there are certain percentage of crossover is given between the two genes. Now we have to put it in order, like A and B is 8%, B and C is 8.5%, C and D is 18.5%, A and C is 16.5%, B and D is 10%. So this is called the crossover gene and this is the crossover percentage. Now when we do this, now we have to see that linearity should be maintained according to the crossover. So between A and B, suppose we say this is A and this is B, so it is 8 units. Then between B and C it is 8.5 units. So we say that C is here, which is 8.5 units. But next we see between C and D it is 18.5. So if we put D here 18.5, others should also comply. But we see A and C is 16.5. So A and C is coming 8 plus 8.5 is 16.5. Now B and D should be 10. So if we put suppose D here, then this is 10. That means this is 2. Now see the distance between C and D. So C and D is 8.5 plus 8 plus 2. That is 16.5 plus 2, 18.5. So it is matching. So D should be here. But if we had placed, suppose A and B here, 8 and B and C here 8.5, then we put that C and D, suppose C and D here we put D is 18.5, then this A and D distance would not map, or B and D distance would not, because B and D is 10 unit, so B and D will become 26.5. So that means this is not wrong. This particular order, linear order, is correct. So this is how we map the chromosome. The numbers will be given, crossover of the genes and crossover percentage. You have to map according to the order of this percentage crossover. Thank you very much.